9 sales representatives, 6 men and 3 women, at a small company wanted to attend a national convention. There were only enough travel funds to send 3 people. The manager selected 3 people to attend and stated that the people were selected at random. The 3 people selected were women. There were concerns that no men were selected to attend the convention. A. Calculate the probability that randomly selecting 3 people from a group of 6 men and 3 women will result in selecting 3 women. To solve this problem, let the variable W represent the event of selecting a woman and let P of W and W denote the probability to select a group of 3 women. Applying the general multiplication rule for dependent events, we are going to compute the probability that 3 women be selected from a group of 6 men and 3 women. To compute this probability, we have to multiply the probability to select a woman the first time times the probability to select a second woman given that the first person selected was a woman, times the probability to select the last woman given that the first 2 selected persons were women. Using then the value 3/9 for the first probability, 2/8 for the second probability, and 1/7 for the third probability, the product of these 3 numbers will give approximately 0.0119. Based on your answer to part A, is there reason to doubt the manager's claim that the 3 people were selected at random? Explain. To answer this question, we have to be aware that the calculated probability to select 3 women is only 0.0119, which means that even though this event is not impossible, it's very unlikely to happen. Then, somebody may think that the selection of the 3 women was not really random, as manager claims. To better understand the previous conclusion, let's visualize all the possible combinations by gender of 3 representatives to attend this convention. From all these combinations, what is the most probable group to be selected? We may have a group of 3 women, another group with 2 women and 1 man, another group with 1 woman and 2 men, and the last group with 3 men. Computing the corresponding probabilities for each one of these combinations, we know that for 3 women the probability is 0.0119. For the group of 2 women and 1 man is 0.2143. For the group of 1 woman and 2 men is 0.5357, and for the group of 3 men is 0.2381. According with these numbers, the most likely combination to be randomly selected to attend this convention is the group of 1 woman and 2 men. An alternative to calculating the exact probability is to conduct a simulation to estimate the probability. A proposed simulation process is described below. Each trial in the simulation consists of rolling 3 fair 6-sided dice, 1 die for each of the convention attendees. For each die, rolling a 1, 2, 3 or 4 represents selecting a man. Rolling a 5 or 6 represents selecting a woman. After 1,000 trials, the number of times the dice indicate selecting 3 women is recorded. Does the proposed process correctly simulate the random selection of 3 women from a group of 9 people consisting of 6 men and 3 women? Explain why or why not. To answer this question, we have to consider that the process to select the group to attend the conference assumes that 3 different persons are going to be in this group. Then, the probability of the next event is affected by the event before. In probability terms, this is a random sampling with no replacement. In the proposed simulation using 3 dice, although it is considering the 2-to-1 women-men ratio of the 6 representatives group, the probability to get a number in one throw is not affected by the previous result. In probability terms, this is the simulation of a random process with replacement. In conclusion, the proposed simulation does not represent properly the original selection process. Let's do some computations to clarify the previous conclusions. Let's compute, using the proposed simulation, the probability of the compound event select 3 women. We roll 3 dice, and when we obtain 1, 2, 3 or 4, we select a man, and when we get 5 or 6, a woman. The probability to select 3 women in this simulation is the probability to get a 5 or a 6 in the first roll times the probability to get a 5 or a 6 in the second roll given that we got a 5 or a 6 in the first one, times the probability to get a 5 or a 6 in the third roll given that we got a 5 or a 6 in the 2 previous ones. But given that the events are independent, we have that the probability to get 3 women in this simulation is going to be the product of 3 probabilities to get 5 or 6 in 3 consecutive rows. The product of these 3 probabilities will be 0.037037. Although this is a theoretical probability computation, the proposed simulation assumes a large number of trials, 1000. So it is possible to think, according with the large number rule, that this simulation will give an experimental probability very close to the obtained above. We can then conclude that the proposed simulation does not represent properly the original selection process.